Okay, so let's look at exercise 1.7. We need to show that any regular language is also a context-free language. We sort of intuitively already know that to be true because a DFA is just a PDA without a stack. Let's prove it formally from the definitions. Well, what's the definition of a regular language? It's anything that can be created with a regular expression. And what's the definition of a context-free language? It's anything that can be created with a context-free grammar. So I'm going to demonstrate that we could take a regular expression and convert it to a context-free grammar. Okay, so regular expression to context-free grammar. So what's our base case? We have to be able to convert all the base cases. So if it's the empty regular expression, then we just draw no production rules. If you recall the definition of a context-free grammar, it has a set P, which is all the production rules. I can just make P empty. No production rules, I can't produce no strings, so I produce the empty language, so I can do the same thing the regular expression does. If a regular expression can make epsilon, well then I just add a transition from the starting state to make epsilon. And if the regular expression can make the token x, well then from the starting state I just produce x. So those are my base cases done. Let's look at the step cases. So for the step cases, I'm going to assume that R1 and R2 are regular expressions, and they have context-free grammars G1 and G2, and the starting states are going to be S1 and S2. And I just show I can build clean star, concatenations, and unions. Okay? So if we want to make the union of two regular expressions as a context-free grammar, well, it's easy. I can take these two context-free grammars and add a new state where I either choose the starting state of this CFG or the starting state of this CFG. Right? So what's this going to produce? Well, it just produces whatever G1 can do, which is the same as R1, or it produces whatever G2 can do, which is the same as R2. So I can do unions. Can I do concatenations? Well, of course I can, exactly the same way, right? I make a new starting state, and then I do S1 followed by S2. So I can do concatenations. Clean star is the only slightly interesting one. If I want to be able to create the clean star closure of R1, I need to be able to replicate the starting state of G1 over and over and over again as many times as I want. So how am I going to do that? I make a new starting state, and I can add S1 and another S, which will sort of loop back over itself, or I can make epsilon, because I could choose no many copies of R1. And since I can make all the base cases into context-free grammars, I can make all the step cases into context-free grammars, I can take any regular expression and convert it to a context-free grammar by sort of like doing these rules over and over again.